For the talking on the mastering modern software distribution. He'll talk about challenges on on-prem, air-gapped, and build your own cloud setups.
Thanks, Radu. So yeah, let's get started. My name is Philip Miglinci. I'm originally from Vienna, studied there, and yeah, Vienna University of Technology. After that, I became actually the CTO of an alerting company, where we spend a lot of time alerting firefighters to get to their fires, integrated into the state alerting and dispatching system. So like working for Kubernetes and on-premise deployments for quite some time. And always was super interested in open source and all the technologies around Kubernetes, like Docker and so around. Last summer, we spent a lot of time, 2023, we co-founded Glasskube. Last summer, I spent a lot of time in San Francisco attending YC, and which gives us the possibility to continue building on open source products and projects. So what we're talking about today is most of us would prefer to have one simple SaaS platform running in your own cloud or on your own servers, and all your users just connecting to it, using it, and being happy. But for some software vendors, this is not reality. Some software vendors really need to ship their software to their customers. These software vendors, these ISVs, are forced to do that by their customers because of several reasons, right? So the customers, often in regulated industry, have some kind of data sovereignty and control. I wouldn't say anxiety, but control. So they really want to have all the data on their premises, in their clouds, and in their infrastructure. But they still expect to have some kind of autonomy. They want to be in charge often of updates and management, but they still want to be guided by us as the software vendors. And if something breaks, they still need your time or your support. And the natural thing to do is that, who knows, the startup series, Silicon Valley, the natural thing to do is even when some smaller companies approach us, is how to ship my software on-prem, put everything in a box, ship it to the customer, plug it in, and it should work. And actually, we know some customers who are actually literally doing this, shipping hardware boxes around the globe, said, yeah, just auto DHCP, connect to the IP and everything works. And it actually does work, but it doesn't scale. And another example which we saw, which we thought and saw in the past, which we think was kind of the reason why we started Distro in the first place, is this kind of instructions. So you zip your repository, you send it to the customer and give them basic instructions. Unzip it, Docker Compose build, Docker Compose up, and yeah. And then they send out actually a new version, created a Docker Compose, new directory, my app new, and all the Docker services got a new name, and nothing worked. And we thought, man, there are still companies distributing software this way. We should do better. And yeah, so what are the first things that comes into mind if you want to ship your software to your customers' premises? I always ask software vendors what are your third-party dependencies? I also talked with Alessandro today and said, yeah, he easily integrated Auth0, a SaaS solution, or you can use Stripe for payments. But all these third parties won't be available if you deploy your software to the premises of your customers. There's often limited internet connections or some other limitations where you cannot connect to them. So the first thing is really application design. Reduce all your third-party dependencies, especially online services or services that might not be available everywhere in the world. And the second thing is, how do your commit messages look like, right? This is something super important because often the commit message is the foundation of your release notes. And your release notes often, your releases are the foundations of your versioning. And you don't want to just push a commit and deploy the commit. This works if you have one deployment target, right? But if you ship your software to your customers, you end up with multiple versions being used at the same time. And if you cannot keep track of which customer uses which versions, this might get a mess pretty quickly. Then we're gonna take a look at how do you perform releases. especially if you have like multiple components into multiple repositories, how to bake everything together. It's like, are all your packages on a snapshot version if you're from the Java world, or are you using just latest, or like, does all your package JSONs have like 1001 version because you don't update it? And even if you do releases, do you really follow semantic versioning? We all know major version, you need to increase it if you have like a breaking change. Minor versions are for features, and bug fixes are in the patch version. So if you have a patch, just do the patch version, and else it's the best way to follow the semantic versioning. This will also give your customers, your end customers, the confidence when to update and what to update. Let's look at the commit history. I think the page is a little blurry, but this is actually a screenshot of the commit history of distr. It's like our software distribution platform, which looks really, really, I would say, beautiful, because like every commit is associated with a pull request. Every commit has a clear scope. It's like either a fixed commit, it's a chore, or it's a feature. And even like with the prefix of the conventional commits, you can easily then create automatic release notes. So if you see that you're adding a new feature, you put the feature prefix, and then the release automation automatically knows that it should create a new minor version. If you're just having a fix or chores, you just get an automatic new bug fix release. But although the commit history is really, really nice, the pull request before that was really ugly, and you see like tons of commits, the builds are failing most of the times. They're like reviews, rebases, yada, yada, yada. But I think the best way in order to get around this is like always use squash merges. And like one of the like best open source repositories in terms of like community contribution, styling guidelines, which we learned a lot for, is like the Renovate repository itself. You know, the bot similar to the Bender bot who constantly creates pull requests if a dependency is outdated. These guys are really, really good in terms of community management and open source repository. And we adopted and recommend a lot of the guidelines they do. So like we create usually this kind of pull requests, we squash merge it into the main branch, and after that we have another beautiful automation which is called release please. And this is also what like would be best practice for all the releases. So if you you don't need to write your changelog and everything by yourself, right? You can have a bot that passes the commit history of what actually changed and updates the ticket, and also a changelog file in the background automatically. And it also keeps track of what's the actual next release number. You see it in the title of the pull request, and it will also be automatically updated based on the commits. And the funny thing is, often like creating a release cannot be as simple as like merging a pull request, but actually with release please it is, because often in a release you have to update the package JSON because there's your version, then you have your version used in your documentation somewhere, you have your version used, I don't know, in your Helm chart for example, and using release please you can actually, like this is the release please config and it's sadly again blurry, but you can specify like specific paths and JSON paths. So example in this case, the release please automatically looks at the package JSON, and then it uses JSON query to determine the version and see if the version string is there like matching the previous release. It will automatically update it to the new one. You can do the same thing for the package log or for a Helm chart version. And you can also do like some comment annotation. For example, looking at what release please actually does. So the pull request that release please creates like will update all the versions we saw in the first place, and also images with the for example X release please version comment. You can do this in a README or in any other file you like. Perfect. And after that we have a beautiful release and we have a version scheme. So to have like a clear application without any third-party dependencies, a clear versioned artifact where the version is like part of the Docker tag, and in all the like log files, package JSON files, and so on. So I think now we are ready to ship our application to the customer. but how? How to ship it once we got the release? And believe me, getting great releases using versioning cohesively and consistently across all like projects and sub-projects is like really the first and important step, especially if your repository is like distributed, or like your application is distributed across multiple repositories. You can use like also automations like release like renovate to automatically create pull requests into your main repository. And if we're looking about the deployment models, we all want to have, what we want to do is like SaaS. But as we said before, SaaS often doesn't work out for our end customers. So there are like three main differences between the BYOC and self-managed. And it's all about the question, who manages the infrastructure? It could be like a cloud hyperscaler, it could be like an on-premises data center, or some hybrid environment. And if we look at like some kind of metrics, we see it's like, it ranges always from low to high in terms of like customer control, right? In some kind of SaaS setup, there is little to no control by the customer over the infrastructure used by the vendor. In terms of like self-managed or on-prem, the customer manages everything and the vendor basically manages nothing. And then there are like some kind of new paradigm shifts out there. More and more big companies actually leverage bring your own cloud. I think Databricks, Retool, and a lot of these companies are saying, okay, you want your data in your infrastructure on your cloud account, we can make this happen. Just give us access to your cloud account and we will manage the infrastructure, which technically is your infrastructure, but managed by us. And this kind of bring your own cloud deployment models come more and more into play. And they're tricky because they still require you as a software vendor to manage diverse infrastructure, because some customers are on Azure, GCP, or on AWS, and you need to kind of distribute the software from your CI/CD into their cloud accounts, because normal stack you use some kind of integrated container registry with AWS, but this might not work if your customer is running on-premise, how to pull and fetch the images. And in order always to bring an image from A to B, I think a container registry is really the go-to tool to use. What's really recommended is like push all the artifacts to the container registry, and OCI images are so versatile. You can push all the Docker images, you can push your Helm charts, you can push your Terraform modules as your OCI artifacts. And then your clients can easily pull them. They will probably upload it to their own registry, and then we'll do some advanced security checks. But the first thing you always want to do is like use minimal images. For example, there's a great Google project out there, Distroless. If you're having like a Go server, it's like a binary. You can make a new Docker image from scratch, or like a Distroless image, and then you have really only your binary and no third-party dependencies which might be vulnerable or can get easily attacked. And then obviously, what you also want to do if you distribute your images via the container registries, attach your signature. Use cosign or Swift to also attach your SBOMs, because if your SBOMs are and the signature is part of the OCI image, also your end customer will have additional trust in the artifacts, because they can see which, like say, materials are used, or who signed the image and is it authentic. Another way which is super important, you might want to restrict tags to users. You don't want to give any tag to any user. You might want to say, okay, only your customer A and B are receiving version 1, and the other customers don't. And in the next step, you want to analyze the download history. So if you look at, for example, our container registry, this is like the download history. And this is also a really great tool. If your software runs in the vendor's premises, you need to guess which version they're running on. But tracking exactly like which tag was pulled from which IP address, you can approximate, okay, they pulled the version 2.8, they're probably running on 2.8 because they didn't pull any version after that. And you can easily say, manage artifact licenses. So I only want my customer to get access to the tags A, B, C, or D. And I think the second big paradigm in bring your own cloud or self-managed infrastructures are always deployment agents. So if your customer is open to have some kind of third-party software running inside their infrastructure or their cloud, deployment agents are definitely the way to go. You can run a small like sidecar inside the cloud, which like constantly fetches the state from the upstream. You can actually use like Flux reconcile or like Flux Argo CD. You can use like distr agents, will like constantly pull the latest state from an OCI registry or from a GitHub repository or from a third-party backend like distr, and reconcile and see if the application is still running, and are also able to push some kind of metrics out, either as a status in a custom resource or like to an endpoint or open telemetry or anything. And these agents are obviously also then able to perform some updates, as I said, reconcile deployment target state, and agents are out there for everything, like Terraform, Docker, Kubernetes. There are some projects that actually abstract like Terraform runs inside of custom resources. So you can use this inside Kubernetes, and you can also integrate this directly into CI/CD. But what about air-gapped, right? So we now talked about that we can move the OCI containers to the registry, the customer can pull it, or you can like invite them to use your agents in order to automatically update and reconcile all the logic. But in terms of like an air-gapped, in terms of an air-gapped deployment, your agents will not be able to connect to the container registry, or your agents will not be able or like your application will probably not work because you have some kind of third-party Docker image downloading from the Docker Hub or GitHub container registry. And there are some open source tools available. One of them is like XAF. It's developed by Defense Unicorn from the States, and it actually has a very, very nice approach. It's a command line tool where you can create like some kind of XAF package. And there you can specify, for example, a Helm chart or a list of containers. And then XAF will create one big XAF application bundle. So it will look inside the Helm chart, look inside the Docker Compose, and recursively fetches all the images into one big XAF OCI application. And then you can push the XAF OCI application inside your target air-gapped Kubernetes cluster. And if in your target air-gapped Kubernetes cluster there is no container registry or Git server, you can actually use XAF to bootstrap the container registry and the Git server inside your air-gapped cluster, because everything is bundled in XAF, or will be like downloaded from the computer connected to both the air-gapped cluster and the system. And then it will pull out our resources from, and then push and deploy the resources to the air-gapped cluster. So this is also one of the tools which integrates with us and all the supply chain, like software supply chain, to push to the air-gapped clusters. So we have now, I think, time for questions, and I can also give you a short demo about the distr platform, how it looks in action, to manage like different deployments. Are there any questions right now? Yes.
So if you're making the SBOM and
yeah.
deploying that to your customers,
yeah.
Whenever you find out that anything in your SBOM was compromised in any way, dependency or something, what is the means of communication to those customers if you don't have access to their own code?
Gotcha. So once the SBOM is stored in a container registry, it's often the job of the container registry to constantly check if there are some vulnerabilities in the dependencies of the container image. But as long as you also have the same container images inside your scope, you can use some automated workflows or manual emails to send, hey, it seems like you pulled version 2.8 from our container registry, and which is affected by a vulnerability. We already pushed version 2.8.1, which fixed the vulnerability, but you didn't pull it yet, so we can like assume that you're still affected. So in terms of like this kind of software delivery, we cannot be for sure what's there in real time, but as long as we know that the latest version wasn't pulled yet, we can assume that they might be affected. But the SBOM is also always like baked inside the OCI image, so it's also part of the image. And so it gets shipped with the cluster and without. Perfect. then I think we have 5 more minutes for a demo. So, okay, I didn't plan it that good. Oh, thank you. For example, this is like the vendor platform where you have an easy overview about all your deployments across like multiple of your customers. You're gonna see like where the installed agents are, and the agents are able to report back a status if something is okay, has an error, or is like stale, which means that the can you hear me? Right. Oh, they can hear me. I think it's fine. I think for the camera. You have an agent where you get the status report back if something is okay, error, or like stale. Stale means we didn't hear from a deployment target for a long time. And the second way of deploy to like your customer's infrastructure is definitely the artifacts. So we can really see like which customer pulled which artifact. For example, we see the customer with the small monkey downloaded the backend and the frontend in the v1 tag, and this is still okay. But the customer named Philip, that might be me, downloaded Glasskube in the version 0, but there's already a newer version available. So we have the real mix between like the agents and the artifacts, having like one unified overview about all your customer deployments, where you can give them licenses. And yeah, I think these are like the best practices for on-premise, air-gapped, or BYOC software delivery. And everything you see here is like also completely open source. It's called Distr, it's on GitHub. And yeah, thank you so much. And yeah, if you want to connect with me, these are like the QR codes.